Bismillah ar-Rahman ar-Rahim, my dear Vascular colleague. I'm going to speak today about an interesting new topic, which is robotics and artificial intelligence in vascular ultrasound, what it can do. My name is Dr. Muhammad Omar Al-Farouk. I'm a consultant vascular surgeon. Let me take you first to a car which is driven by artificial intelligence. If you can see this video, this video is by Tesla company, which manufacture cars. They mentioned that they are a computer company that manufacture cars, but they are not a car company. You can see Tesla have 8 cameras. It has machine learning. It gives you the estimate surrounding of the car, the speed of the car, how fast is the car in front of you. If there's anyone crossing the traffic, it gets around 38,000 picture per second. All this is being analyzed. It will give you the traffic lights, if you are able to pass or stop, and what distance from the car in front of you. Let us think of this way as a blood vessel. So artificial intelligence can very easily navigate blood vessel. It is so much easier than traffics. They also use a high-speed internet, and this is already fact on the ground. So what we can do, we know that ultrasound in vascular surgery, there is operator dependence, which is factors that hinder. Not all ultrasonographers have the same expertise, and there is no unification in their definition. It's also time consuming. It takes 1.5 hours, and there is always waiting list, and there is a limited accessibility. Sometimes it's not 24/7 available, especially with a skillful practitioner. So these are the current difficulty. How robotics can help us in ultrasound? Actually, if you think of robotics and artificial intelligence, what is the first thing that AI can replace doctor? The first one is that it can replace sonographer, because this is artificial intelligence manipulation of vessels. You can have the procedure totally automated, so robotic can do the duplex scan. There is improving of position. Robotic can position the probe of a high frequency in special areas with accuracy, with higher accuracy, and there is consistency and repeatability. So you have the same ultrasonographer which do the same procedure on the same patient, and you don't have the difficulty of having chaperones, male and female, sonographer, and so on. So this is what robotics can benefit. It definitely will be better accuracy, will be much quicker. It can work 24/7. You don't need to have rest or vacation. It will be repeatable, and it will be more comfortable for the patient, and you will get a faster diagnosis as well. Now, this is the vision of robotic ultrasound. It's a robotic arm attached to artificial intelligence. Here is the sonographer, and this is the robotic arm, and it can replace the sonographer. One of the first company to move into this arena was Philips. You can see Philips, they use Epic pilot study, and this is the model. This is the robotic arm, and this is the duplex machine, and the artificial intelligence is down here, and will control the movement of the probe. This is a demo, which is torso demo, plastic, and you can see here in this video, the machine can move the probe. It can move it up and down. If let us say this is superficial femoral artery, so it can move up and down and get you the measurements. And with machine learning, it can adjust the probe. This is usually easy by convolutional neural network, CNN. And this, it can track not only the blood vessel, but even can track a guide wire and can track anything inside. You can see this is a guide wire, and you can put in the program just to follow the guide wire either in TS, transverse section, or longitudinal section. And this is already done by Philips company in the demo mode, and we think we will get the first version probably within 1 year's time. So you can see how accurate it is. And there is obviously ethical consideration with artificial intelligence. Data must be privacy with security, and the AI algorithm must be fixed without any bias to address the potential disparity. This is the machine by Philips, Eliquis, with the robotic arm, and here is even putting gel on the skin is done by another robot that can inject gel as you go along. So that is why when you visit the Royal College of Surgeons of England, if you go to the main entrance, this is the first thing you see in the Royal College of Surgeons of England at Lincoln in Enfield. You will see Da Vinci 2.0 with the 6 arms. So definitely, this is the future of surgery. Definitely, the hand will become less. And definitely, the Royal College is with the future of surgery, which will be robotics play a major role. Now we know in neurology, robotic TURP is much safer, even less expensive than TURP and less side effect. It's now becoming a standard of practice, and I'm sure it will spread into multiple speciality. One of the very big hospitals in artificial intelligence and robotic is Guy's and St. Thomas's Hospital by Professor Murad Salam, Professor Hani Zaid. They have around 8 robotic machines with multiple artificial intelligence program. So this is another video that will explain to you that this is the machine, artificial intelligence machine with a robotic arm. It's an easy model, as you can see, and you can see the sweep of trajectory detection, which means it will automatically detect the blood vessel. And when you move, so here is the robotic arm, just to put the initial position, and then you give the order to trace the probe, and you can see it will trace automatically the probe. Now it will perform a trajectory, which means if you give information, follow the blood vessel, you can see it moves direction because the blood vessel here, superficial femoral artery, have a sweep. So it wants to be perpendicular to the blood vessel, and you can see how it moves and readjust itself. And if you get a sudden movement, it will stops. And this is an advantage. So it can go backward to start reassess situation and go onward. And here every image will be have GPS location in the body. And this is a big advantage because when you get a stenosis in a duplex scan, you're not sure where this exactly is. It middle of the thigh and which millimeter it is. But this method, you can get exactly where the image was taken. And this is a big advantage because the hurdle for us to put ultrasound images into artificial intelligence is that we are not sure which part of the body this image was taken in order to be reproducible. So you can see here is the machine and the robotic arm move with it. Now there is an FDA approval of doing echocardiography by robotic arm. This is the echocardiography machine. The operator just put the machine on the chest, and this is already have an FDA approval. So it is approved in the States that you can do echo in a patient which will be in a different setting, and you can get the reading, and artificial intelligence can print the report automatically. So you can see this is a beautiful system that you can follow the ultrasound. This is another company which can do duplex ultrasound to the hand to the digital artery, you can see the screen will identify the hand, identify the joint, and then the robotic arm will go into measuring the flow velocity in the digital arteries. Each finger have two digital arteries on both sides, and you can see the signal, and then it will do the scanning, then go to the second finger and do the scanning with very high accuracy. So this is already existing technology in 2024, and I'm sure it will be rapidly developed because this is the first thing that robotic can do in vascular surgery. My conclusion out of this lecture that robotic and artificial intelligence will transform vascular ultrasound. The importance of continued innovation and ethical consideration is very important, and we need to encourage further research and collaboration in this field. I am sure one of the first field that robotic will play a major role is robotic ultrasound, because the advantage is clear and the technology is there. Thank you very much. I wish you all the best, and I hope it was of benefit to shed a light on robotic ultrasound scan. Thank you very much.